Welcome students to today's class on scientific notation. Now over the summer you may have been in the United States of America and you might have found yourself looking up at the sky and seen a solar eclipse because of the presence of this little thing which was the moon blocking your view. And you might have wondered, wow, how far away is the sun? I wonder how far away that sun is. Well, it's about approximately 149.6 million kilometers between us mere earthlings and that star in the sky we depend on so much. Now, that is a very, very large number, obviously, 149.6 million kilometers. Another way of writing that is to put in all of the zeros. Now, scientists can be quite lazy. They don't have a lot of time to mess around with things. They want to find things out quickly. Writing zeros, terrible waste of time. So scientists have devised this a way so that they don't have to put in all the zeros, and a quicker and more efficient way to denote numbers. That is what's referred to as scientific notation. So if we take this number 149,600 and then lots of zeros, we can tidy this number up and write it in a different fashion. So how do we do that? Well, it's quite simple. We take this decimal place and the decimal place right here, and we start moving it until we reach a point where this number over here, this significant number, is between 1 and 10, just like we make it here between 1 and 10. So we start moving 1, 2, 3, 4, 5, 6, 7, 8. So this in effect is actually dividing that number by 10 8 times. And it gives us this number here, 1.496. Nice easy number. Now because we divided it by 10 8 times, we must go and multiply it back in by 10 to the 8, so 10 to the power of 8. So that we end up with the same number, so that we can say that these two numbers here are equivalent. So you can see that this number here, 1.496 by 10 to the 8 kilometers, much tidier and easier to write. So this doesn't just relate to small numbers, it also relates to big numbers. So if we look at this this map of the sun right here, this little picture of the sun, and we look at these things zooming out of the sun, if you like, right now, and they appear to be solar prominences, which you might have talked about in grade 9. But if we delve right into the sun, what we see in there are not balloons, not in fact balloons, but the little things that balloons are made up of. So these balloons are made up of what we know to be helium, and they're made up of little helium atoms that look like this. With our electrons, you might have take you back to the Bohr-Rutherford diagrams. There might have been lovely little electrons zooming around these points, whizzing around the outside. Now, how big is each one of these helium atoms? Well, it turns out that they're incredibly small. So a helium atom is 0.00000000000 27 zeros, and then we hit 646 kilograms. So this whole number here. Now, obviously, scientists do not want to be saying those zeros or writing those zeros, and to save you from listening to me talking about all those zeros, we can rewrite it using scientific notation. Now, the number is a very, very small number, so instead of pulling this decimal place to the left, in order to make the beginning number between 1 and 10, it's important that we move the decimal place to the right. Now I begin moving it to the right, and you can see we count as we do. And as we move that decimal place to the right, we'll see that it moves actually 27 times. Yes, this is a very, very small number. So it is the size of one helium atom. And we've moved it 27 times to the right. Now, in order to show this using scientific notation, we are now left with a number which is 6.46, which is what we ended up with here. Okay, that is between 1 and 10, but we had to move it 27 times to the right. Now, because you moved it to the right, you show that with a negative sign to denote that it was moved to the right. So essentially, you are multiplying, when I moved the decimal place, I was multiplying that number by 10 27 times to reach the 6.46. So I must then show that you, in order to make the numbers equivalent, that you divide by 10 27 times. And that's what 10 to the negative 27 means. It actually means 1 over 10 to 27, or divide by 27. Divide by 10 27 times. Examples right now. I'm just going to introduce two concepts as we do. When you look at scientific notation, there's two important parts to denote. One here I've shown in red, and that is called the coefficient. It is also sometimes referred to as the mantissa. The mantissa, or the coefficient. It must be between 1 and 10. The second part that's very important is this part here, which can be negative or positive, and that's referred to as the base. And in scientific notation that we're going to cover, that base is to the base 10, nice decimal form. Okay, so if we have this number 6.5 by 10 to the 4 newtons, this ginger-haired bombshell is pushing the car, the blue car, with a force of 6.5 by 10 to the 4 newtons. That's something that you guys are going to become very familiar with in the next couple of weeks. And we can say that the ginger nut is going to push the car over the cliff. Why they're pushing it over the cliff, I have no idea. So to look at this particular scenario, 6.5 by 10 to the 4 newtons is the amount of force that's used. 6.5 by 10 to the 4, that represents quite a large number. Hopefully you can see that by 10 to the 4, the base number is positive. That means that we must, in order to work this from scientific notation back to normal notation, we must multiply that 6.5 by 10 4 times. So we would take our 6.5 and we're going to multiply it by 10 4 times. So let's have a look at that. 1, 2, 3, 4. Okay, so what do we do in this scenario to get back to usual normal notation? We must fill in zeros at these points where we move the decimal place. So you end up with a figure of 65,000 newtons. Now, of course, we can show this the opposite direction. We take this decimal place, 65,000 newtons. We move it to the left, 1, 2, 3, 4. And you go back to scientific notation, 6.5 by 10 to the 4. Okay, so that is an example of moving from scientific notation back to normal notation. Use a small number, and we use this number 2.52 by 10 to the negative 6. How can we get from scientific notation back to normal notation? Well, we're going to take our 2.52, and now we're going to have to move it 6 times. We're going to have to move that decimal place. I guess the question is, what students find confusing, do I move it left? Do I move it right? Well, just stop and think about it for a second. This is a negative exponent, which means that the number is small. It means the negative exponent means that the number is going to be between 0 and 1, the number you're going to end up with. In order to make sure that that number ends up between 0 and 1, we're going to have to move this decimal place to the left, not the right. So we move it 6 times. 1, 2, 3, 4, 5, 6. And we're going to fill in our place zeros. And then we're going to end up with the decimal place here. So we get the number 0.0, 2, 3, 4, 5, 2, 5, 2. So you end up with 0.000000252. Hence the need for scientific notation so we don't have to write and say all those zeros. Is it important that you put in all of the numbers here, 252? Yes, it is. We'll talk about significant figures, or sig figs they're sometimes called. And they're an important part of science, and they relate back to accuracy of measurement. Denote this in your calculator. Let's say you have a nifty calculator called the Cybolt 3000, and you want to put in this lovely number here, 7.5 by 10 to the 4, and you're wondering, how do I do it on the calculator? Well, it's actually quite easy. Calculators come with specific buttons which have EXP or EE usually on them, and they actually are set up and they mean 10 to the something, 10 to the X. So it would just be a case of putting in 7.4, and then instead of actually writing multiply by 10 to the 4, you would just hit the button EXP, which means 10 to the, and then put in 4. So those final two steps, you'd say your 7.4 EXP 4. Obviously, if it was a negative, you'd say EXP and then hit the negative button on the calculator and then 4. Okay, so that's just an introduction to scientific notation. Hopefully this has strengthened your knowledge of it, and it's very, very important that you've also done the practice questions. We'll maybe do more practice tomorrow in school also.